Welcome to my series into Microsoft Fabric, DP-700. In this video, we will look at data pipelines in Microsoft Fabric. What are pipelines? A pipeline in Microsoft Fabric is a way to move and transform data. Instead of manually copying or running scripts, a pipeline chains these steps together in an automated workflow. Each step is called an activity, and pipelines can run many activities in sequence or in parallel. Typical use cases include copying data from a source into one lake, cleaning or transforming data, loading data into a lakehouse or a warehouse. Pipelines are how you orchestrate ETL, which is extract, transform, and load, and ELT, which is extract, load, and transform processes inside Fabric. Pipeline activities. An activity is a single task inside a pipeline. Each activity performs one step in moving or transforming data. Common types of activities include a copy activity, which moves data between systems, for example from Azure Blob Storage into a lakehouse. A notebook activity, which can run a PySpark code for custom transformations. A SQL activity, which executes T-SQL scripts inside a warehouse, such as running a stored procedure. A dataflow activity, which triggers a dataflow Gen 2 for low-code drag and drop preparation. You can think of an activity as one building block. By chaining these blocks together, a pipeline creates an end-to-end workflow that brings data from source to destination. So, dependencies overview. An activity inside a pipeline is linked together through dependencies, which controls the flow, how the flow continues. There are 4 dependency conditions which you can see on the image. The first one, which is at the top, is called onSkipped. The next activity runs if the previous one was skipped. OnSuccess, which is the green tick, this means that the next activity runs only if the previous one succeeds. The next one, the red X, is on failure. The next activity runs only if the previous one fails. And the last one, the blue arrow, is on completion. The next activity runs regardless if the previous activity succeeded or failed. We will now look at an example of dependencies between activities. In this example, you can see that the first activity, logic that fails, has 2 different dependency conditions. One is what happens if it succeeds, and one is what happens if it fails. So we'll look at the succeed path first. So if activity 1 succeeds, it'll follow the green arrow up to upon success. As this one succeeded, this one will then run as well. As this one will also run, it will then look to this here dependency condition, which is if skipped. So if this one is successful, this one will run on to be successful, and this one will not run because it has not skipped. If we look at what happens if it fails, it will then follow this red arrow and it will go to upon failure. Again, this here activity will run. So, to summarize, if this activity is successful, it will run onto this one. If this one is successful, this will not run. If this is successful and this is skipped, this one will run. If this fails, this step will run. Example 2 of dependencies between activities. In this example, we have a first activity that has a condition of what will happen if it fails. It then goes on to error handling, which has 2 different types of activities. One is what happens if it skips, and one is what happens if it runs. So, if this one fails, it will then run onto this. If this one succeeds, it will run to here. But, interestingly, if the first activity fails, this here activity will skip. And if this activity skips, it will also run this next activity. So that means regardless if the first activity fails or the first activity succeeds, this here final activity will run. So dependencies deactivated. Activities in a pipeline can also be deactivated. This means that they don't actually run during validation or pipeline execution. Instead, they act as placeholders. They are useful for testing or commenting out parts of a pipeline without deleting them. During runs, they never execute. Instead, the output the placeholder status you choose. An example of a deactivated activity would look like this, and you can see that it appears grayed out with a symbol at the top left. When you deactivate an activity, you choose how it should behave in the next step. So you can mark it as succeeded, such as here you can see that there is a green tick. You can mark it as failed, which would then be a red X, or you can mark it as skipped, which would then be this grey arrow symbol as well. So if you mark it as succeeded, downstream activities with on success or on completion will still run. It will act as if it succeeded. If you mark it as failed, downstream activities with an on failure or on completion will run, as it will act if it was failed. And if you mark it as skipped, downstream activities with on skipped will run. This makes pipelines flexible and fault tolerant because you can switch off problem steps temporarily, test alternative flows, or keep placeholders for later development. Parameters and variables. In pipelines, you can set parameters and variables. Parameters are defined when pipelines start, manually or on a schedule. The values do not change during the run. They are best for inputs that say constant, for example, file paths or a specific date for a run. For example, you can set a parameter for file date equals a certain date, and all activities can use this date, but it stays the same from the start to finish. Alternatively, pipelines are created inside the pipelines, and they can be updated as the activities run. They are best for values that change during the pipeline run. For example, a counter or a temporary values passed into these steps. For example, a variable could be row count, which at the start you could say equals 0, and it is then updated after each copy activity finishes. So the main takeaway to show the difference between parameters and variables is that parameters have fixed inputs, such as arguments that you pass into a function that do not change. Variables, on the other hand, have dynamic values, such as normal programming variables, and they change as the pipeline runs. And monitoring in pipelines. You can monitor pipelines in Fabric to track progress, performance, and errors. To do this, you can look at the pipeline run activity, which shows every time a pipeline was triggered. You can see when it started, how long it took, and whether it succeeded or failed. You can look at activity run details, which let you drill down to each activity inside the pipeline. Here you'll find logs, error messages, and the exact output for each step. You can look at alerts. You can set up alerts to notify you if a pipeline fails, runs longer than expected, or hits an error. So why does monitoring matter? Monitoring is critical in production. It's how you make sure data is moved reliably and how you can quickly debug issues before they impact reports or downstream systems. Error handling in data pipelines. In Microsoft Fabric, error handling is about what happens when something fails. The aim is to keep pipelines running reliably and to spot issues quickly. The key features include retry policies. Activities can be set to retry automatically if they fail. For example, a copy activity could retry up to 3 times if it encounters an error such as network timeout. Dependencies. Control flow is managed with options such as on success, on failure, on skipped, and on completion. These decide what runs next depending on the outcome of the previous activity. Alerts. You can configure alerts to trigger when a pipeline fails, runs too long, or meets certain conditions. This is especially useful for monitoring in production. Monitoring and error outputs. Each run generates detailed logs. Errors can be reviewed in the activity run details and see exactly what failed and why. Now on to some questions. Question 1. What is the primary role of a pipeline in Fabric? A. To visually design KQL queries for Event House. B. To automate data movement and transformation across activities. C. To manage Fabric capacity scaling. Or D. To structure data in Delta tables. And the answer is B. to automate data movement and transformation across activities. Pipelines are automated workflows. They can have one or many activities that run in sequence or in parallel. This is how Fabric manages ETL or ELT processes such as copying, transforming, and loading data. A is incorrect as KQL is used in Event House, not pipelines. C is incorrect as scaling is handling at the workspace level. D is incorrect as delta tables belong to the lakehouse or warehouse. Question 2. What happens if an activity is deactivated in a pipeline? A. The activity is skipped, but dependencies still decide the flow. B. The whole pipeline fails immediately. C. The pipeline deletes that activity permanently. Or D. The pipeline runs all activities regardless. And the answer is, of course, A. A deactivated activity is simply skipped. The pipeline continues, and dependencies such as on success or on failure decides what happens next. B is incorrect as other activities can still run. C is incorrect as deactivation does not remove the activity. And D is incorrect as dependencies are always respected. Question 3. Which statement best describes parameters in Fabric? They are fixed at design time and never change. They are values passed in when pipeline starts. They are outputs automatically generated by each activity. Or they are the same as variables. And the answer is B. They are values passed in when the pipeline starts. Parameters are values you pass in at the start of the run. They make pipelines reusable, for example, by passing different dates or file names without editing design. A is incorrect as they are not fixed forever. C is incorrect as outputs are separate from parameters. And D is incorrect as variables are different because they change during a run. Question 4. Which dependencies ensures an activity runs only if the previous one fails? On success, on failure, on skipped, or on completion? And the answer is on failure, B. On failure means the next activity only runs if the previous one fails. This is useful for error handling, such as sending alerts when something breaks. And question 5. How do you monitor if a pipeline has failed? A. Look only inside a copy activity settings. B. Wait for an email notification. D. Build a data flow Gen 2 report. Or D. Use the pipeline run history and logs. And the answer is, sorry, I've got that mixed up. The answer is D. Use the pipeline run history and logs. Run history shows every pipeline run, and the log explains the errors in detail. This is the standard way to monitor success and failure in Fabric. A is incorrect as that only checks one activity. B is incorrect because emails are optional and unreliable. C is incorrect as data flows are not for monitoring pipelines.